Measuring 1000 amps directly would be quite difficult. Directly coupled metering devices used in low energy power systems are not suitable for high energy measurement. That's why we use current transformers. Devices that accurately reduce high currents to lower values for safer metering applications. But how do current transformers operate? And why is it vital that you know about them? A current transformer, or CT, is a device used in high-energy power systems for metering applications. In high-energy switchboards supplying hundreds or thousands of amps, a direct reading current or power meter is not a practical consideration. In such situations, the current transformer is used. A CT works like a step-up voltage transformer. A double-wound step-up transformer has more turns on the secondary winding than on the primary winding. This results in a higher output voltage than the input voltage on the primary winding. The value of the output voltage is determined by the ratio of secondary turns to primary turns on the transformer. A ratio of 1 primary turn to 10 secondary turns will produce an output voltage 10 times greater than the primary input voltage. Current ratios in a transformer are inversely proportional to voltage ratios. This is also true for current transformers. So the secondary current of the CT will be significantly less than the primary current of the conductor being measured. Examining the design of the current transformer, we observe that the primary winding of the CT is made up of a single conductor, such as a cable or bus bar, which passes through the toroidal core of the CT once. Here we see the real CT set up for operation. The secondary winding of the current transformer is wound around the toroidal core. Depending on the CT design, the full load secondary current will be either 1 or 5 amps when the full primary current is flowing. The secondary winding of the CT is connected to an ammeter designed to read a value of 1 or 5 amps at full capacity. As an example, a 1000 amp CT with a 5 amp output will produce 5 amps in the secondary circuit when the bus bar passing through the centre of the CT is carrying 1000 amps. There are no components in the CT secondary circuit other than the meter itself. Because an ammeter's impedance is very low, the connection produces a short circuit on the secondary winding. Whenever primary current is flowing, a proportional secondary current is also flowing through the meter circuit. The meter scale is calibrated to show the value of the primary current, not the actual secondary current in the meter circuit. The CT is designed to work constantly at full secondary current without damage. Whenever an ammeter needs to be disconnected from the secondary winding, the output must be shorted to maintain loading and prevent a dangerous voltage buildup across the open output terminals. CTs are common items in the electrical industry and are routinely used in metering applications above 100 amps. Which one of your personal electrical meters contains a current transformer?